So let's see. The biggest takeaway, it's pretty self-explanatory. Plan and architect before you code. Yeah, so I understand this to be a necessity because of two reasons. I would say one, because you don't want your code to be a mess, and two, security. So in one of your examples, you mentioned how in the Linux kernel example, we don't want our file system communicating with, who was it exactly? I forget. But either way, the point is, if we do not properly architect or properly plan out our code, we can run into issues like certain places are going to communicate with another, memory leaks, yada yada yada. I don't have that great of an example because I'm not in the industry, but you see what I mean. So let's see. So an example software architecture graph. Here's one I found of an Amazon Web Services solution. So let's see. So this is pretty much just showing a web app with essentially two zones. So if I remember correctly, the Amazon availability zones are just like servers or server farms placed in different areas, like different countries. So what this is explaining is that you have a domain, you have a host, and then you have your web app. Here, I guess your visitors will be distributed by load balancer when necessary. So then it automatically scales from this web server, maybe in California, and if you have a user in New York, it'll go to this web server. And I guess the same goes for the availability regions, or the availability zones. So if this is all taking place in the US, then we can have another zone that takes place in Europe. I don't know exactly what a bucket is. That's kind of dumb of me. So I assume bucket is just a place where data is held or stored, because I remember we had bucket sort. But yes, and then in the end, your data or the data is sent back to the client, and then along with that, sequentially we have analytics that are sent to you. So yeah.